Hi everybody, welcome back to the channel. In this video we're going to take a look at finding the area between two curves, and that is not to be confused with finding the area under a curve. So I want to illustrate kind of the difference and some of the language that we use, and then we'll take a look at a couple of examples. So first of all, the area between two curves we are always going to talk about as being positive. So this is a little bit different than what we've seen where the area under a curve, or thinking about the net area, could be negative if you have more of your area under the x-axis than you do below the x-axis. In this case, when we're talking about the area between two curves, we're talking about that area always being positive. So let's take a look at kind of a graph, and basically here's the thing you should think about with notation is when you hear the phrase area between two curves, we don't really care about whether that area is above or below the x-axis. Doesn't really matter at all. Okay, this is not what we call signed area. So let's say, for example, you have something like this, and I guess we won't worry about them kind of where they keep on going after that. We'll just look for now at kind of this area right here. I don't really care about the fact that some of this area is above the x-axis and some is below. Really only care about what is the positive value of this area that's between the two curves there. Okay, so the way that you can think about this is, let's say we call one of these f of x and the other one g. So we'll give a name here. So this one's f, and then we use green over here. This other one is going to be g of x. Okay, so when we think about f and g, if we want to find this area here between them, we want to know that in this area, kind of starting at a point A and ending at a point B, which one is higher, which one is above the other one. So in this case, I hope, even though I'm just kind of hand-drawn this, I hope what's clear is that f is larger than g on the interval from A to B. And so they have endpoints of where they intersect. We'll deal with kind of multiple intervals here in a minute, but let's say that this value where they first cross is A and then over here is B. So from A to B, f is higher. And so if we want to find that area between the two curves, we could call this the integral from A to B of, this will be dx on the end. And way to think about this is that this is f minus g. Okay, f minus g. If you take f minus g, it's basically saying combine the two functions into one function, put their difference with the x-axis as being the area that you kind of think about. So if we were to kind of graph f minus g here together as one function, it would look a little bit something like this. It would kind of start at the x-axis here, it would kind of end at the x-axis, and it would go up something like this and kind of be somewhere there. And we're basically saying find this area. And this area has the same area that f minus g has. So this section is not actually going to be that much different than what we had before, but just now the difference is instead of an area under a curve where we cared about the x-axis, now we're talking about the area between two curves. We're just going to take one function minus the other. So we can always find the integral of f minus g dx from A to B. And you might think about, well, what if f is not higher? What if g is higher that whole way from A to B? And so if that's the case, well, then you could do g minus f, or you could just do f minus g and say, hey, you know what, take the absolute value of whatever you get there, because the absolute value is just going to take whatever area you would have had. If g was higher than f, then you would actually get a negative value for the integral. I guess you could put the absolute values outside of the integral there. You would actually get a negative for the integral, and then great, just take that area and make it positive, because we're always talking about a positive area there. So let's take a look at an example of being able to find the area between two curves. We're going to start out with something like f of x equals e to the x, and g of x equals just x. And we're going to look at this on the interval from 0 to 1. Okay, you might have an idea of what this graph looks like in your mind. There's your line. Let's see, your your e to the x has a y-intercept of 1 and then just increases like this. So 1 is always higher than the other here, and we're going to go from 0 to 1. And so really what we're looking for is what is this area right there. Okay. Well, to find that area, you can find the integral from 0 to 1 of either f of x minus g of x or g minus f. Now remember, we're supposed to get a positive area. So let's try it as f minus g. This is actually going to be the correct way because hopefully by looking at these graphs, we know that e to the x is always higher than x. Okay, so that's fine. Basically, we're saying take the integral from 0 to 1 of e to the x minus x dx. And this is a definite integral, so we should be getting an area. And this is pretty nice because when we take the integral or find the antiderivative here, we get e to the x minus, let's see, it would be an x to the 2 because you got to go up by a power of 1. Then you need a 1/2. And this is evaluated from x equals 0 to x equals 1. Okay. And so then go ahead and plug in 1 and plug in 0. You get e to the 1 minus 1/2, and then minus e to the 0 minus 1/2 times 0. Well, let's see. 1/2 times 0 is just 0. E to the 0 is 1. So really your end result, you get something like e minus 1/2 minus 1. And you can figure out what you get as a decimal there as well, which is approximately something like 1.2 something something something. Okay, and so we do get a positive area in there. So it does bring up the question, and we kind of addressed this, but let's just see what happens. What if we had done it in the other order? What if we had done the integral from 0 to 1 of g minus f instead? Like, what if we didn't know which one was higher? Now, we do. We drew the graph. We know what the functions look like. But what if we didn't know that? Okay, let's see what happens. This would be the integral from 0 to 1 of x minus e to the x dx. And then you'd basically do exactly what we did in the last problem. You just kind of have things flipped, which terms you have flipped. So this is 1/2 x to the second minus e to the x, evaluated from 0 to 1. And so let's see, this is 1/2 times 1 minus e to the 1. And then minus, in parentheses here, this would be 1/2 times 0 minus e to the 0. So basically you get something like 1/2 minus e minus 1. Nope, just kidding. That should be a plus 1 because we've got to distribute the negative. Okay, so 1/2 minus e plus 1, which is going to give you something like negative 1.2 something something something. Okay, well, if we got a negative answer and we're looking for the area between the two curves, that means we messed up the order. And so, okay, what do? Well, I'll just take the absolute value. And so you should get 1.2, something, something, something. Because it really, we didn't know this, or, well, we did know this, but pretend we didn't. It should have been f minus g. Okay, we should have gone in the other order. Now, this is assuming that your two functions don't actually cross somewhere on the interval. So it brings up an interesting question. What if from 0 to 1, your two functions did something like this? Okay, and you were looking for the area between the two graphs, which would mean you want this area, but then since you're going all the way up to 1, you also want this area. This would technically be the area between them. But both of these areas are supposed to be positive, because remember when we talk about the area between the curves, we're talking about always having a positive area. So here's what we're going to do in this case. This first area that's supposed to be positive, we'll call that R1 for region 1, or call it area 1. And then this second region is going to be R2. Okay? And so if you can find the point in the middle where they cross, basically set the two equations equal to each other and solve for x, if you can find where that happens, okay, then you can go ahead and integrate not once, but split up the integral into two separate integrals. In other words, you could do, like, let's say, let's again give these some names here. Let's call this one f, and then this one here would be g. So what you would have here for your first integral, the first integral would start at 0, and it would go to whatever this question mark is. So 0 up to wherever that point is where they cross, whatever that x value is. And in that interval, the first region over here, f is higher than g, so we should either do f minus g, or if you did g minus x, you just have to take the absolute value. Okay. Now, we also need a second integral, and that would go from question mark, from that point, up to 1. And now in that second interval, that second region over there, g is higher than f. So technically, we would need g minus f dx, or if we didn't know that, we could do f minus g and take the absolute value. But here's what you can't do, is if they cross somewhere in there, you can't take the integral from 0 to 1 of f minus g and just say, hey, take the absolute value of whatever you get. For all you know, these two areas undo each other and they're exactly the same area, and if you got something like 0, you should say, wait a second, that doesn't make any sense because I have a positive area and I have another positive area. I'm supposed to add those together. I can't get 0 there. So if you had done that, that would be assuming that you kind of cared about which one was higher, where it's possible to get a negative area there, but we've said that that's not okay, that's not possible. So you would actually have to split up your integral into two different integrals if they cross once in there. Okay, you could actually have it where they cross more than once. I mean, you look at some different sine and cosine curves, you could have a function where, you know, you have something like this, and going from A up to B, maybe they cross, you know, a few different times in here. And so maybe they cross right at A there, they cross here again, they cross here again, and then kind of stop at B right there. So all the way from A to B, that's what you're talking about. You actually need to split this up into one integral for this area, another integral for the second area, and then another integral for the third area right there, and figure out three different integrals and figure out what's this x value where they cross, what's this x value where they cross, and look at all three of those different regions separately because they all should have a positive area. And then you should have an integral representing each one of those areas. Okay, so just be really careful about that. My recommendation is before you jump into a problem that says find the area between two graphs, you should probably graph both of the functions and change your window on your calculator from like your x minimum value to be a, your x maximum value to be whatever b is, and then see, do they cross in that interval? Okay, because if they cross, then you got to find where they cross, and you got to find what's that x value, and then use different integrals there. Now, if they don't cross, you're fine. You can just do one function minus the other function, take the integral. If you did it in the wrong order, just use the absolute value. But the case to worry about is, do they cross somewhere in there? That's the situation to look at. Okay, hope you've enjoyed the video.